Good morning guys and welcome to Mind Your Math. Today we move on to the second shape in the chapters of surface area and volume, which is cylinder. Now you have seen examples of cylinders very often in your house itself. The gas cylinder that is being used in your house is in the shape of a cylinder. Now a pencil which is not sharpened is in the form of a cylinder. Okay, and look at this pencil. It is in the shape of a cylinder. Okay, now this box is in the shape of a cylinder. So what is basically a cylinder? A cylinder is a solid which has got two circular surfaces and a curved surface which joins those circular surfaces. Okay, so here I have a circular surface, here I have a circular surface, and here I have got a curved surface, right? So let me try to draw the diagram of a cylinder on the board and see what are the terms and the definitions associated with it. So here you have a cylindrical shape. As you can see, or you have seen from the solids, two circular faces and there is a curved face. Okay, now since the ends are circular faces, these circular faces should have a center. This is a center. If we join the centers with a line, this line is called as the axis of the cylinder. Okay. Now, this particular axis has to be perpendicular to the base of the cylinder. Suppose this is the base of the cylinder. This axis perpendicular to the base of a cylinder gives a right circular cylinder. Okay. If this axis is not perpendicular to the base of the cylinder, we get a cylinder something like this. Okay, this axis should have been here. Instead of that, this axis at an angle to the base. Now, for your particular class, we are studying only about right circular cylinders. This involves much more complicated maths. Okay, now when you are trying to find out the area of a cylinder, you should know that this particular cylinder can be assumed to be composing of circular disc like this, stacked ones. Now, I am unable to draw. So, if we have gone to a chips shop, you know the chips that you eat, the banana chip shop, you have seen, if it is freshly made, you have seen how the guy in the shop keeps on slicing the bananas and giving out perfect circular disc. Okay, if you stack all those discs back, only the circular disc back, you will get a cylinder. So a cylinder can be supposed to be composed of circular disc. So if you keep slicing the cylinder, what you get are circular disc. So a single cylinder, I can say that it is composed of circular disc. Okay, now let us try to find out the total surface area of the cylinder. Before moving on to finding the area of the right circular cylinder, we have a few more terms to discuss. So here you have a base, here you have the top face, here you have the curved face. Now the curved face is also called as a lateral face. So lateral face is synonymous with curved face. Okay. Now because you have the top and the base faces in the shape of a circle, we have the radius, which is this length. We also have the height of the cylinder, which is basically the length of the axis from center to center. Okay, that line should be perpendicular to the base. That will give you the height of the cylinder. So these are the basic terms which you should be knowing about when you are talking about a cylinder. Now let us figure out how to find out the area of a cylinder. So now I showed you a simple example of a cylinder, which is this. Okay, so I told you that area consists of all the places where I can run my hand. So I can run my hand over here, I can run my hand over here, I can run my hand over here. Okay, now you know that the top part is a circle. Now what is the area of a circle? If the radius is r, the area of a circle is pi r square. So what is the area of the bottom part or the base? It is again pi r square. So I have got top face plus bottom face plus I need the lateral surface area. Okay, the lateral surface area is a curved surface, right? Now this becomes a lateral surface, this became a cylinder, the top and bottom part, it is open here, but still this is a cylinder, and suppose it is closed, you have a circle here, and this is my curved surface. If I am opening my curved surface after removing the top and bottom, what do I get? I am getting a rectangle, right? So what is the area of this particular rectangle is what we need to find. Now listen here. This is the top part. Okay, I have sliced off the top part and I am going to open the curved surface. Now what can you say about this length? This was the circumference of the circle of radius r, correct? This part. So when I am open, that 2 pi r becomes like this. So this length is actually 2 pi r. Okay. And I have the height h. So here also I have got a 2 pi r and I have the height h. So I got a rectangle of sides 2 pi r and h whose area is given by L into B, which is 2 pi r into h. So I got my LSA as 2 pi r h. So the total surface area of the cylinder is area of the top face pi r square, area of the bottom face pi r square, and area of the curved face, which is 2 pi r into h. So now you have understood how you got the total surface area of a cylinder and how the cylinder was opened in order to form a rectangular face. Okay. Now let me ask you a question. Suppose you are given this rectangular sheet of paper, and suppose the same sheet of paper is given to you and your friend. I am asking you to make a cylinder, or at least the lateral face of the cylinder. So what you do is that you fold it. Now you fold your paper this way. When I say that, this is your length, this is your breadth, so you fold it lengthwise. But your friend decided to do it breadthwise. Now I am asking you to find the total surface area of the cylinder that both of you have made with this particular sheet of paper. I have written the measurements for both of you and your friend while making this particular cylinder. Now this was my sheet of paper. I told you, you folded the sheet lengthwise. So my 2 pi r, the base, the 2 pi circumference of the base is the length now. So I have written over here. I found out the value of the radius, which is 7 centimeters. Now your friend, what he did was that he did it something like this. Okay. Now my radius value has changed. So whenever you are given a sum wherein it is said that a rectangular sheet of paper of a particular measurement or dimensions, they will give you the length and the breadth. Is folded lengthwise in order to make a cylinder. Please take 2 pi r is equal to length. If they say it is folded breadthwise, then 2 pi r is equal to breadth. So please read the question carefully. This is actually the reverse process of opening the cylinder. But when you are folding the cylinder, you need to know whether you are folding lengthwise or you are folding breadthwise, because it will make change to the base area. Reason being, it will make change to the radius of the cylinder. Okay, so I hope you have understood, and please make it clear this distinction before you approach any sum like this. We have been discussing about the TSA of a solid cylinder. Now we also need to discuss the TSA of a hollow cylinder, which is also very important. So let us see how to get the TSA of a hollow cylinder. Look guys, we were talking about solid cuboid and we were talking about hollow cuboid. Similarly, you have to understand that all solids, they can be solid or they can be a hollow one. Now we talked about a solid cylinder wherein they will give you some information like the height of the cylinder or the radius of the cylinder, find the TSA, etc, etc. They will not give you the thickness. The reason being, it's a solid, it's completely filled with whatever is the cylinder made of. But in the case of a hollow cylinder, you know it is not like that. It is something like this. There is space inside. There is space inside and there is a thickness over here. Okay. Now they will ask you to find the TSA of this particular cylinder. We should know how to find out the area and what is the change that you should make when you are finding out the area of a hollow cylinder. When you are studying a formula, you should have some basic idea about where the formula has come from. See, as such we study a hell lot of formulas without even knowing where they have come from. Like we learned Pythagoras theorem. We don't know where the proof is from, right? Similarly, there are so many formulas which we cannot get access to the proof. We know it is very difficult at our school level. So what we do is that we just learn the theorem or we just learn the formula and we by heart. But wherever possible, you should know where the formula has come from, because in the cases where you know where the formula has come from, the questions can get that much tougher. Okay, so in the case of a hollow cylinder, in the case of any solid for that matter, sorry, I have told you that area is a space where we can run our hand. Okay, in the case of a proper solid cylinder, I showed you how to find the area. In the case of a hollow cylinder, let us see which are the places where we can actually feel the surface. Outer curved surface. So, okay, now, sorry, inner curved surface. So, I have got only the radius will vary, the height will be the same. Okay, so this is my outer radius, this is my inner radius. Now, let us see what happens to the top and the bottom faces. Okay, look at the top face. Top and bottom faces, it will be the same, right? Top face, there is nothing over here. I can't run my hand there. I can run my hand only over here. Now, what does this look like? This is more like a circular disc. Now, what is the area of this disc? If the outer radius is r and the inner radius is small r, what is the area of the bigger circle? Pi r square. What is the area of the smaller circle? Pi r square. So, this whole area minus this small area should give me this shaded area. This is a surface over which we can run our hand as far as the base is concerned. So, the same is applied for the top also. So, this into 2. So, what we get finally as a TSA of a hollow cylinder, we will see now. You will get, so let me write the outer radius with a capital R and the inner radius with a small r. Easier to identify, okay, because that is what we have used over here. So, let us add up everything. You will get 2 pi RH, outer curved surface area, inner curved surface area, okay. Now, we can simplify this formula, we can take the common factors out. So, let us try what we are finally getting, but basically this is what you should remember. Don't go in for complicated, stuff like simplifying, oversimplifying, all those things, because if in case you need to eliminate one area, suppose you are given a cylinder with the top open, then you should know how to take out the area from this part. Okay, we will do a couple of sums wherein you will apply this formula in various forms. So anyways, we will simplify the formula first before that and see what we are getting. So when I am simplifying, this is what I am getting. I have taken a 2 pi outside, 2 pi h outside, so I get r plus r plus 2 pi into r square minus r square is of the form a square minus b square. I split it as r plus r into r minus r. Now you can see that 2 pi and r plus r is a common factor. So this is what I am getting. So see, I have seen this formula, many books referring to this formula as a simplified version, but I don't know whether it looks more complicated than the original one. But please, for your information, stick to this formula, because anytime you want this, you can always simplify in 2 steps. So this is the formula that you should remember in order to apply to all the sums henceforth. Okay. Before I move on to the sums, there is one more small point that I need to make. It is very obvious from the diagram itself. Suppose you have a hollow cylinder. Right? This is the thickness. Correct? Because there was a thickness and we had a hollow space inside, we started deriving this formula. Now, you know that this radius is capital letter R. This radius is small letter r. So, what is our thickness T equal to? It is small r minus capital R. So, this is one small addition that I wanted to make to the formula that we have done. So, now let us get on with the sums. CSA of a cylinder is 88 meters square and the height is 14 meters. Find the diameter of the base. Now we know that it is a normal cylinder, it's a solid cylinder because nothing is mentioned about the thickness or it being a hollow cylinder. Safely you can apply our original formula of a solid cylinder. So what is given to you? It is given that CSA is 88. So what is the formula for the lateral surface area of the cylinder? We have learned that it is equal to 2 pi RH. That is equal to 88. Now the height is given to be 14. So 2 pi into R into 14 is equal to 88. So we can find out R from this. Now, whenever you are substituting the value of pi, always make sure that you substitute the value 22 by 7. Do not put the approximation 3.14 unless it is specifically mentioned in your question. In some questions, they will give take pi equal to 3.14. If they say like that, you can use 3.14. Otherwise, please go for 22 by 7 itself. So here what do we get? 88 by 14 into 2 into 22 by 7. So I will be getting, correct? So when you cancel, you will get a 4, 2. So it is 4 by 2 into 2, which is 1 meter. Now this is the value of the radius. 2 times R, which is 2 meters, right? An iron pipe 20 centimeter long has a thickness of 1 centimeter. Okay, so if the external diameter is 25 centimeters, find the surface area. So we need to find the TSA or the total surface area, and the pipe that is given to us is very evidently a hollow iron pipe. The reason being the thickness is also given and the external diameter is specifically mentioned as 25 centimeter. So we need to find the internal diameter in order to move on with the sum, in order to find the TSA. So let us first write down the formula for the total surface area of the pipe. Area of the outer curved surface, area of the inner curved surface, area of the two ends. Okay, now let us find out all the values, or let us first see which are the values that are given to us in the sum. So it is given, the thickness is given to you 1 centimeter and the external diameter is given to you, which is 2 times R is given to you as 25. Okay, now R is equal to 25 by 2 centimeters or 12.5 centimeters. Now let us see how we can find the value of the internal diameter or the internal radius. You know that our thickness is equal to R minus R, right? So my small r will be equal to R minus T. That is 25 by 2 minus 1. So it will give me 23 by 2 centimeters. I am going to retain it as fraction itself because you know my obvious problem with decimals. You can use decimals if you are more comfortable with decimals during the calculation. So after finding the value of the inner radius, I have substituted it directly in the total surface area formula, which is 2 pi into R. R is 25 by 2 into H 20 plus 2 pi into R 23 by 2 into 20 plus 2 pi into R square minus R square. Okay. Now, instead of calculating each term individually, what I have done is that I have tried to simplify the calculation by taking the common factor out. So, 2 pi and 20 is common and by 2 is also common in these two terms. 2 pi, 20, 20, 1 by 2, 1 by 2. I have taken it outside. So, inside the bracket, I get only 25 and I will get a 23 also. If I am trying to calculate each term individually, I'll have to do this calculation, then I have to do this calculation, and then I have to do that. In each term, whatever is the common factor, I will be repeating my multiplication that many times. So instead of doing that, I have taken out the common factors in order to simplify my calculation. Now, 25 plus 23 is 48. Okay. Now, the second term, you will get pi by 2 into 96. How you get is, this is 2 pi, 25 square by 2 square and 23 square by 2 square. So you know that in both the terms 1 by 2 the whole square is a common factor. So I have taken it out. So it is a 1 by 4. Inside 25 square is 625. 23 square is 529. When you subtract that, you will get a 96. 96 is easily divisible by 2. I get a 48. Now you can see that 48 is a common factor in both the terms. So I take a 48 out, I get a 20 plus 1, which is a 21. So this is what I am getting. Now I substitute the value of pi. So when I am substituting the value of pi, I can see that 21 and 7 get cancelled very easily. I end up with a very simple multiplication and I get the answer as 3168 centimeters square. Whenever you are doing the calculation in this particular chapter, instead of doing each part of the calculation individually, return it to the end, take out the common factors, simplify and then calculate. Right? The radii of two cylinders are in the ratio 2:3 and their heights are in the ratio 5:4. We need to calculate the ratio of their curved surface areas. So instead of finding out the curved surface area of one cylinder, we need to compare the areas of two cylinders. So let us call it as cylinder 1 and cylinder 2. Okay. Now the radii of two cylinders are in the ratio 2:3 means if the first cylinder's ratio is 2R1, the second cylinder's ratio is 3R. I will take it as R itself. Now the heights are in the ratio 5H and 4H. Now we need to find the ratio of the curved surface area. So what is the formula for the curved surface area of a cylinder? 2 pi RH. So 2 pi into R into H. Right? Now when we substitute 2 pi into 2R into 5H, here I will get 2 pi into 3R into 4H. We don't have to find absolute values. So the individual values of radius and height is not required. We just need to find the ratio. So let us see what is the ratio we are getting. So you will get 2 pi into 2R into 5H by 2 pi into 3R into 4H. Let us cancel out the common terms. So you will get 5 by 6 or the required ratio is 5:6. Very easy sum, just cancelling out the common factors will give you the answer for this. A rectangular sheet is rolled along its length to form a cylinder. If the size of the sheet is 44 centimeters by 18 centimeters, find the radius of the cylinder. See, this concept I have already discussed when we are folding the paper along the length and along the breadth, which measurement we should take as a circumference of the base. Correct? So we will go through it once again. Whenever the size of the paper is given as L into B form, you also always need to understand the first measurement goes as the length and the second measurement goes as the breadth. That much is clear to you. Now, this is a paper, rectangular sheet of paper. So this is 44 centimeters and take this as 18 centimeters. It is said that the paper is rolled along the length. So now my 2 pi r becomes the length. Correct? You can see that 2 pi r becomes the length. Suppose the question was it is rolled along the breadth. So now my breadth measurement becomes a circumference. Okay? So please keep this in mind when you are doing the sums. I am again telling you, and it is very important so as you do not make a mistake when you are taking the measurement for circumference. Okay? So now let us get on with the sum. So you can find out the value of R. Okay. Now, after that, we need to find the radius. Okay, fine. You need to find only the radius. You don't need to find the TSA also. So, let us find the value of the radius over here. It is 7 centimeter. A very simple sum. Only thing is that you need to know which measurement you should take as a circumference. The diameter of a garden roller is 1.4 meters and it is 2 meters long. How much area will it cover in 5 revolutions? Now, you know what's a garden roller. It is in the shape of a cylinder. If you have not seen it, in real life, at least you have seen it in the movies. So, it is in the shape of cylinder. There is a handle, which doesn't matter over here. We need to find out the area covered by the garden roller in 5 revolutions. Now, the diameter is given to you. You can find the radius of the garden roller and it is 2 meters long. So, when the length of the garden roller is given to you, it basically means the height of the garden roller. Now, what is the area covered in 1 revolution? Only if we know that we can find the area covered in 5 revolutions, right? Now, this is a garden roller. Now, there will be handle over here and it will be used like this. Now, suppose the garden roller, or this is the point where it is starting to move from, or this is a point where it is touching the ground. Okay, so I'll keep a post-it over here. Okay, now it is rolling like this, and when it comes back into that particular position, we say it is one revolution. The complete one cycle is one revolution. So what happens in that complete one cycle? The entire curved surface area gets covered once. So you can say that when the garden roller is moving in, like for one revolution, one curved surface area is getting covered. So in 5 revolutions, 5 times the curved surface area is getting covered. In this particular case, we are not bothered about the base or the other end of the garden roller. The reason being, it is not touching the ground at all. Okay. So here I have completed the sum and I have found out the area covered in one revolution. 2 pi RH, I have got it as 8.8 meters square. So the area covered in 5 revolutions is 8.8 into 5. Okay. Now let us move on to the next sum. So the diameter of a garden roller is 120 centimeter and it is 84 centimeters long. It takes 500 revolutions to level a playground. Find the cost of leveling it at rupees 1.50 per meter square. Now it is again the same concept. There is a garden roller. You know that the area covered in one revolution is equal to the curved surface area. It is taking 500 revolutions, means the area covered in 500 revolutions is 2 pi RH into 500. So let us start the sum. But first and foremost, convert all the measurements into a single unit. So here you have 84 centimeter, 120 centimeter, and you have 1.50 per meter square. So I will retain the measurements in centimeters itself, and finally I will convert the area into meter square. Okay. So here I know that diameter is equal to 120 centimeter. So I know the radius is equal to 60 centimeters. Height H is 84 centimeter. So in one revolution, area covered is curved surface area 2 pi RH 2 into 22 by 7 into 60 into 84. Okay. Now you know that this can get cancelled out, 12. So you will get 44 into 60 into 12. Okay. So find out the value for the curved surface area. 31680 centimeter square. Okay. Now this is the area covered in one revolution. So what happens in 500 revolutions? So 31680 into 500. Okay. Now let us find out the area that is covered in 500 revolutions. In 500 revolutions, this is the value that you are getting, 1584 followed by 4 zeros. Now our area is in centimeter square, but the cost is given in meter square or per meter square. Now you have an option. You can either make this into meter square or you can convert this part into centimeter square. I will show you both the ways. Depending upon which one you are more comfortable with, you can follow that process. Okay. So I hope you have understood the sum and how we got the area, because I am going to erase the remaining part in order to show the conversion part of it. Okay. Look guys, when you are taking the examination and you are having this sum and suddenly you find that you have forgotten the formula or the value for conversion, because there is a table wherein you know that 1 meter square is equal to so and so centimeter square, or 1 centimeter square is equal to so and so meter square. So you can directly apply over here. Suppose you are forgetting it. Okay, you don't remember because you have already attention. There are so many formulas to remember, whatever. In order to convert this into meter square, what is 1 centimeter square equal to? It is basically 1 centimeter into 1 centimeter. Right? Now, centimeter to meter conversion, definitely, I mean, even a 5th grader can remember. So that is 1 by 100 meter into 1 by 100 meter. So I will get 1 by meter into meter is meter square. So 1 centimeter square is this many meter square. So this much of centimeter square is actually equal to 1584 meters square. Now, the cost per meter square is given to you. To find the total cost, you have to multiply 1584 with 1.50. So here what I have done is that I have converted the area which was in centimeter square into meter square. Now, you don't want to convert the centimeter square. You are more comfortable with the centimeter square. So you have to convert the cost what is given in meter square. So what is given to you? Rupees 1.50 per meter square. What does it basically mean? Let us write in plain English. 1.50 for 1 meter square. Right? Now, rupees 1.50 for 1 meter into 1 meter, or rupees 1.50 for 100 centimeter into 100 centimeter, or centimeter square. Correct? Now, 1.50 is the rate for so much of centimeter square. Okay. So for 1 centimeter square, what is the price? How many centimeter square do we have now? So 14840000, so much of centimeter square we are having. For 1 centimeter square, this is the price. So for this many centimeter square, multiply with this. Did you understand? You can convert whichever unit into whichever comfortable unit. Okay. Now the only thing is that make the conversion correctly. In case you are forgetting it for the examination, this is how you do it. Just remember that centimeter square is basically centimeter into centimeter, and meter square is meters into meters. Convert meters into centimeters or centimeters into meters, whichever you are okay with. Okay. Now a very basic thing. So I have just told you in case, because sometimes students come to me and tell that, ma'am, we did not remember the exact conversion formula, so we made a mistake. You don't have to actually remember. You can do this also. Okay. A lampshade is shown in the figure. It is to be covered with a decorative cloth. The frame has a base diameter of 20 centimeter and height 30 centimeter. A margin of 2.5 centimeters is given to be folded over the top and the bottom. Find how much cloth is required for covering the lampshade. Okay, so guys, let us assume this is a lampshade. Okay, and this is the decorative cloth with which I am going to cover the lampshade. Now, in addition to covering the lampshade, the material used is equal, the height of the material used is equal to the height of the lampshade. Now this extra 2.5 centimeters is put into the lampshade. Similarly, it happens at the bottom also. Okay. So in addition to the length of the lampshade, an additional 2.5 centimeters extra of the cloth is also required to fix it into the fold and fix it into the lampshade, and similarly at the bottom. So our effective height would be height of the lampshade plus 2.5 plus 2.5. Okay. Now you know how to calculate the value of or calculate the height. Let us find out the curved surface area. So I have calculated the curved surface area over here. So you can see it's 2 pi RH, 2 pi into 10 into h will be 30 plus 2.5 plus 2.5. So you will get 2200 centimeters square. Okay. So whenever you are having a sum for finding out the area, especially try to, have a picture in your mind of, because most of the things that we are doing in area and volume are real life objects. So try to picture it inside your head, so you will get an exact idea however twisted the question might be. Find the CSA of a closed cylinder 4.2 meters in diameter and 4.5 meter high. How much steel was actually used if 1/12 of the steel was wasted in making the cylinder? Okay. Now, this question has got two parts. One is to find the lateral surface area of a given cylinder. The second part is to find the quantity of the steel, or how much of steel. We need to find the amount of steel that was actually used in making the cylinder under the condition that 1/12 of the steel was actually wasted in making the cylinder. Okay. Now let us deal with the first part because it looks like a very straightforward part. So then we will deal with the second part. Now we know that diameter is 4.2 meters. So my radius has to be 2.1 meters. Height is 4.5 meters. Okay. Now my CSA is equal to 2 into 2 pi RH. I am not writing the formula again. 2 into 22 by 7 into 2.1 into 4.5. Do your calculation. I will be avoiding the decimal. So please get on with your calculation. So 2 into, okay. So I will be getting 44 into 3 into 45 by 100. So you get the answer as 59.4 meters square. So the first part of our sum is over. Now let us deal with the second part. Now, how much steel was actually used, I think, in making the cylinder? If 1 by 12th of the steel that was actually used was wasted in making the cylinder. So if 1 by 12 of the steel was used, what is remaining? 11 by 12 is remaining. So if X amount of steel was used, X by 12 was wasted and 11x by 12 was actually used in making the cylinder. Now 11x by 12 was used in making the entire cylinder, not just the curved surface area, the curved surface area plus the bottom plus the top, because it is mentioned that it is a closed cylinder. So let us calculate now the total surface area of this given cylinder. So you can see that I have found the base and the bottom area by using the formula 2 pi r square. So 2 pi into 2.1 the whole square. So I will be getting 27.72. That is my end areas. Now I have to add the end areas to the curved surface area in order to get the total surface area. Now this total surface area is actually only 11 by 12 of the amount of steel that was used. So I am taking the amount of steel that was used as X. So 11 by 12 X will give me 87.12. Find out the value of X, which will give you the total amount of steel that was actually used, though 1 by 12 of the steel was wasted. Okay. Now we are done with the portion. As I told you, the total surface area of a cylinder is a pretty much easy portion compared to the other topics in this particular chapter. Now if you are having any doubts in this any of the contents of this particular class, mail me at the mail ID given below in the description box.